Welcome to IQAN University. In our last episode, we looked at various input types and worked through assigning them to a module and then setting their operating parameters in IQAN Design. Now let's look at how to set up and assign the operating parameters for a variety of available outputs. Let's start by looking at the current output we created to operate the boom rotate function. The first two properties are simple text fields for name and description. The next property in the list asks whether or not the current output is bidirectional. Because this current output is going to control a hydraulic motor that needs to move the boom both positive and negative, we will select yes. Notice that under default mode, you can see that there are properties for both positive and negative directions. If we were operating a standard pump motor with only one direction, we'd select no, and the negative direction option and properties would be faded out. BWL is where you can add a percentage of bandwidth limiting for fine-tuning the output response during operation. Device type provides a list of common Parker valve coils that will automatically load the parameters. Next on the list is input channel. The input channel is controlled by a function block, typically a math channel, or in this case a dual math channel since it is bidirectional. It will provide the control signal to operate the current output channel. We'll look at this more when we build the control logic in a future episode. Mode selector is used to select a state machine that can allow different modes of operation for the current output channel. This can be used for operator preferences, different workhead attachments, or selecting different power modes for the machine. The last section, default mode, is where you can set the current range and slopes for both positive and negative valve operation. Because there's only one mode of operation currently, it is called default mode. Min and max is used to set the current range in milliamps for the valve based on the valve coil specifications. The command signal will provide a range from 0 to 100%, so in the example shown, an input range of 0 to 100% will produce a valve current of 200 to 1200 milliamps. Below the min and max current settings are start and stop slopes. The start and stop slopes are used to smooth out the command function. They are set in milliseconds and will determine how long it'll take to go from 0 to 100% during start and 100 to 0% to stop. Now let's take a look at the digital output channels. The first one is our light beacon digital output. This is a high side digital output, which is designated by the HS, meaning the output current flows from the output through the load and then to the ground. The voltage will be the same as the module supply voltage. There are two properties associated with the digital output. You can add a delay on, which will cause the output to wait the desired amount of milliseconds after it's been commanded to turn on, or you can set a delay off, which will keep the digital output energized for the preset milliseconds after an off command. Another type of digital output is the low side digital output. These are low power outputs meant for LEDs or PLC signals. For this example, we created one called boom in motion that's able to tell another controller when the boom is in motion. In a low side digital output, current flows from the source through the load and then to the output, which completes the ground circuit upon activation. The last type of digital output available is the high side and low side combination. It allows a group of low power, low side outputs to be energized from a single high side output. These low side outputs have a higher current capacity than the single low side outputs, and they rely on the current limiting provided by the high side output. Regardless of which outputs you select in your design, always refer to the manual for load requirements, as well as any output controlling a valve or other inductive load that must have a clamping diode for protection. We will cover the PWM and diagnostic outputs in a future episode. Tune into our next episode of IQAN University, where we'll begin to create and connect function blocks to start building our control logic.